Okay, before the exam, we were going through the topic of measurement of walls. We have already touched upon it with the substructure. Now we are talking about the walls which are part of the superstructure. We have looked at the sections in the NRM, and it remains the same no matter which type of wall you are doing. So there were some basic principles we discussed. The main thing is you have to take the center line and measurements, and then the dividing line between them is called DPC. The dam proofing course, everything above it is superstructure, everything below is substructure, and the material and the technique can be different for these two items. Okay, we looked at different types of materials we can use in the wall. Okay, and if you are using bricks, which we normally don't use here because of the material availability, but if you are using bricks somewhere in Europe or wherever, you have to specify the type of bond you are using. So the bricks can be arranged in different types, which you can see over there. And then blocks can be simple concrete blocks, lightweight blocks, aerated blocks, and so on and so forth. And then stone masonry or stone blocks, they can be natural stone, stones which are made up of other materials. Okay, and then we have the concrete stones as well. And then we have the special types which consist of glass and diaphragm, which we call as a cavity wall. And then we have the hollow walls as well. You may have seen these hollow walls inside the rooms. In some of the buildings they use it inside the rooms, basically for partition. The hollow walls are basically for partition. Okay, the things which we should consider. What else? Yeah, so walls can be different for internal, external, and then there are projections as well. So external wall is normally heavier and thicker because of the insulation part. The internal walls are thinner and could be of different material. Okay, some examples, and then we the last thing we discussed was case of projection. Okay, now my question is this a projection? Is this a projection? Yes. So anything which is coming out of the wall is a projection, or it could be something else. What? Column. Okay, so you have to be careful. Column is column. So concrete column made up of, it could have steel inside it. You cannot mix them. Okay. So these projections are wall projections. So they are made up of the same material as a wall. Okay, so you have to be careful when you are looking at the plan. Okay, all projections cannot be taken as walls. So for projection, we have the rule here.
The projection only made of
Blocks. Or the same material as a wall. Like wall, okay, because we said wall can be different materials, right? So if the projection is same as the wall, then you can calculate it with the wall. Okay, so we have this rule here. 4 times thickness is more than the, if 4 times of thickness is more than the length of the projection, then we don't need the area. We just need to mention the height. Okay, and the area will go in the description. Okay, and this is the pattern which I told you from the start. When we say we give something in area, so the third dimension is in the description. Okay, so the rule is only changing the representation. It will not change the dimension. The dimension of the projection is still the same, right? 215 by 440 by whatever the height is. Okay, it will not change it. Okay, but if it is following this rule, 4 times of thickness is more than the length, then you will just mention the height, okay, in the dimension sheet. The area will go in the description. And if it is not this, if it is not following this rule, then the projection will be shown same as a wall itself. So you have the height and the length, okay, and the thickness will go in the description, okay. Another thing which was mentioned here, okay, so this is the example. We did it by ourselves, but just for the sake of refreshing your mind, because you had the shock of the exam after that, right? So if you want to calculate the wall for this plan, okay, so you can see the area is not like a complete rectangle, okay. So first of all, we calculate the girth, which will be multiplied with the height, right? The wall is what? The length multiplied with the height. So you can add the lengths together if they are the same, obviously. The height is same and everything is same, then you can add it, obviously. So you look at the top, okay, the length is 6.7 plus 1.8, okay. Then you come here, 0.8, 3.9, okay. And this is one side only, right? So you want to multiply by 2, okay. And then you have to add one more thing, which is these two, okay. They are calling it angles, okay. So this is an angle, this is an angle, and this is a projection. You can see the difference, right? Angle is the wall itself is going up and down. Projection is there's a wall and there's something extra. That's the projection, okay. As I mentioned, all projections are not, or all things coming out of the wall are not projections. You have to look at the material and the structure. Okay, so you will add this 0.8 and 0.8 from both sides. Okay, so 6.7 plus 1.8, the dimensions from the top. This will become the length. Then you have 0.8, 0.3, 0.9 dimensions on the side. Okay, then you add, this will, the first one from the top is the length, the second one from the side is the width, okay. You add them together, you will get two sides, okay, and you will multiply by 2 to make the whole plot, okay. So this is the multiply by 2, so this is the total, okay, total without considering any angle, but we have two extra angles here, okay, so we will add them together, okay. So these are for the angles, okay. So the height plus, sorry, the length plus the width multiplied by 2 for both sides plus the angle, total girth, okay. And then this is, and plus the two angles to take the total girth. And what is this? For the center line, okay. So these dimensions are external dimensions, you can see it here. All of them are external dimensions. So for the center I will subtract, okay. So again the rule, 4 corners, 2 walls, half of the width for the center, okay, half of the width, 225 is the width, okay. So you get the mean girth means center line, okay. So another name for the center line is mean girth, okay. So this mean multiplied by the, what is this? Height, okay, and thickness is mentioned somewhere, should be mentioned somewhere, okay, in the description. Anyways, clear? Okay. Then we have two projections, this one and the top one, okay. If you consider this one, 225 multiplied by 4 will give you more than 0.9. 0.225 multiplied by 4 will give you more than 0.9, right? Or equal to 0.9, sorry, equal to 0.9. We did last time, it was equal to 0.9. So thickness multiplied by 4 is equal to the length, okay. Even if it was more, the rule will remain the same, okay. So you just need the height, and height is same as height of the room, okay. and you can see the other dimensions are mentioned here. Okay, and then you come to the top, 0.225 multiplied by 4 gives you 0.9, and the length is how much? 1.3. So length is more and 4 times thickness is less. So now you have to mention the area. Okay, so area is height and the length. Okay, so 1.3 is the length and height is whatever the height is. Clear? Clear, everybody? Any questions? Okay. Okay, this is the plan which we will do or try to do now. Okay, so we have the whole plot, and then there are rooms given as well, and these walls are different. The external and the internal walls are different. Okay, so you have to calculate them separately. Okay, first of all, now that the dimensions are internal dimensions. All dimensions are internal dimensions, and the thickness you will take it from the text. The height of the floor is given in the text, the thickness of the wall is given in the text. Okay, let us start with the external wall. The external wall is a cavity wall. Okay, so cavity wall will need 3 calculations. What 3? What 3 calculations? When you are calculating the dimension for cavity wall, you need 3 calculations. Yes. Center? No, we are not doing the excavation. Substructure is gone. We are just doing the walls. So for cavity wall, we have 3 calculations. I'll show you the cavity wall. Yes. Block work and which will come after. We are not doing the finishing. Plastering comes with finishing. The wall itself needs 3 calculations. Yeah. Who puts formula for the wall? Huh? Filling, okay. And filling and area. We're talking about that filling. Again, you're still stuck at the exam topics. Substructure, filling and excavation and whatnot. Huh? Yes, right. Half right. Half right. Okay. Half out of the 3 right. There's not even half. Okay. Look at the figure now. Okay. So you see block work on one side, and then you see block work on the other side, and then you have something in the middle. So these are the 3 calculations. Okay. One for the external face, one for the internal face, and one for the cavity itself. Okay. So cavity wall is made up of 3 items itself. Okay. Without any formwork, without any excavation. The wall itself is made up of 3 items. Okay, external, internal, and the cavity itself. Okay. So, going back to the plan, the external wall, I will do as we have done previously. The height is same. For the external wall, the type is also same, right? So let us take a girth, and then you can play around with the girth. Okay. So I can take dimensions from any one end. Okay, they should be same, right? I hope they are. Okay, so if I take the dimension from the top, so I have 350. All right. Okay, 350 means 3.5. These are in centimeters. I don't know why I keep on finding these drawings which are in centimeters. What happened? Okay, so 3.5 plus 3.5 plus what? Thickness of the internal wall, right? Okay, because they are internal, so let us keep them internal. Okay, thickness of the internal wall is given here 100 millimeters. Okay, how many internal walls I have? If you look at the top, the internal walls only one, right? Okay, so 100 means 0.1, 100 millimeters, 0.1. Okay, so this is 7.1, right? 7.1 meters. Clear?
350
In centimeter. Millimeter will be 0.35 meters, so okay, it will be impossible. Okay, only my daughters can be happy with a room of 350 millimeters, and that is only now. Okay, okay, then I add this dimension, which is 700 plus 300 means 7 meters plus 3 meters and 1 thickness again. So 7 plus 3 plus 0.1, which is 10.1. Okay, so 7.1 plus 10.1, total 17.2, right? Okay, and that multiply by 2 for both sides. Okay, and that will be 34.4. Clear? Okay, any questions? Do I need to add anything into this? This is a simple plan, rectangle. Okay, there is no other thing required now. Okay, so this is the total internal girth. 34.2 meters is the total internal girth. Okay, clear?
should we subtract the
Length of what?
blocks?
Not now. Not now. We do it afterwards. Clear? Okay. We will calculate I mentioned earlier as well, the doors and windows. Once you calculate it, then you will subtract it. It's like backfilling. Okay. So this is the internal girth. So I already have the internal dimension. Let me calculate the center line for the internal face of the wall. Cavity wall, right? Internal face. Okay. Internal face, you can see total cavity wall is 265 millimeters. Total. Okay. But this total is divided into 3 parts: internal face, cavity, and the external face. Okay, I'm at the internal side, so I will add half of the internal face to get the center of the internal. Okay, so internal is how much? Well, 100 millimeters. Okay, internal is 100 millimeters. Okay, so like what we have been doing, I have 34.4 plus 4 corners, 2 walls. I'm adding because I'm already inside. Plus half, multiply and okay, or you can write 50 millimeters. Okay, 0.1. Okay, sure. Okay, so this comes out to be how much? 3.
3.8.
Okay, this is the girth for the internal wall, internal face of the cavity wall. Okay, you want the area, you will multiply with what? The height. Clear? The height is 3.6. Okay, so 34.8 multiplied by 3.6. Clear? Okay, obviously you have to write it like this.
Why would you multiply with 3.6?
Height. Clear? Any questions?
3.48, the area. Or the
34.8 is the length only,
yes.
girth. Center line of the internal. Clear? Okay. Okay. Moving on. for the cavity itself now. So I need the center of the cavity now. Okay, I already have 34.8, right? Okay, I will add half of the internal face plus half of the cavity. Clear? I'm at the center of the internal face. I'll add half of the internal, I will get edge of the cavity. And then I will add half of the cavity. Okay? So, half of the internal face is, the internal face is 100. Okay? I will add half of that, and the cavity is how much? 50 millimeters. So, I will add half of 50 millimeters. Okay? Clear or not? Okay. So 34.8 plus 4 corners, 2 walls. I can do half. Okay, fine. Half multiply by 100 for the wall, 50 for the cavity. 0.15. Yes. Clear? Everybody? Three 5.4. Okay, and if you want the area, 35.4 multiplied by 3.6, which is the height. Clear? Good picture? Yes. If the picture is good, it's clear. Yes? How much? 0.27? 127.5 meter square. Okay, now now we are at the center of the cavity, 35.4, the center of the cavity. I need the center of the outside edge now, outside face. Okay, so 35.4 multiply by what? Tell me. 4 2 half of what now? Half of the cavity and the outer wall. Okay, cavity is 50 and the outer wall is 102. You are at the center of cavity, right? You have to add the half of the cavity as well. Okay, 102 plus 50, 157. No, 152, sorry. Hmm. 102 and 50, yes. 3 5. Yeah, 35.4 plus this whole. Point 008. Sorry, yeah, plus. Okay. Anybody has any problem? Clear? She's doing good, right? Okay. I'm thinking about taking only half the lecture, then I will I do my explanation and go, and one of you comes and explain again. It will be good, right? You agree, right? She's doing better than me, right? That's good, no problem. Now so I will multiply with the height, okay? So there is Okay, multiply by the height. Now I will come to the internal walls. Internal walls, all of them same thickness. Okay, and they only need one calculation. You can add the lengths, no problem. Okay, they are separate obviously, but you can add them together if you want. Okay, so for example, we have if I take it from the top, I have a wall. So we will not right now. We are not deducting doors and windows. Okay, they just take the full dimension. Okay, so there is this wall here, this one, which is same as this, right? And this one. Okay, so how many internal walls they have? 1, 2, 3, 4, and 5. Okay. Now this one, and that one. Okay, all of them have the same length, 350, right? The length is given at the top, 3.5 meters. All of them have the same length, which is 3.5 meters. Okay, what is left now? This wall, okay, and this wall is 4 meters. Okay, this vertical wall, and this one is looks like 4.
It's the same as the interior external walls, 40 and 44.
Sorry.
Same
Okay.
as the external dimension.
Say that
40
again.
and 50.
It's 4 meters. Yeah, 4. 4 plus 4 plus 2, 1. Oh, sorry, 10. So 4, yes. Okay. So I have how many walls? 1, 2, 3, 4, and 5, which have 3.5 meters. Okay. No, sorry, not 5. 1, 2, and 3. External I already did. Okay. So 3.5 into 3. Okay. Plus I will add this one, which is 4, and there should be there is a wall here. I don't know why it is not showing, but there's a wall obviously. It's a toilet, so there's a wall obviously. Okay, so this is 2 meters plus this one, which is 4 meters, and then we have one on the top, which is also 4 meters. So this one is 4, and that one, the internal one, the external already done. The internal one is also 4 meters. So 4 into 2. Yes? Nothing? Sure? Clear or not? Huh?
When you will give us a break test?
When you will be relaxed, you stop thinking about it, and then I will, do it.
You surprised us in the test. For nothing this easy. Well,
Yes. Okay. How much is this? 21? 20.5. 20.5. Very good. Okay. If you need the area, just multiply with the height. Okay. It's very simple. Did I miss anything? Okay. Is this clear? Everything is clear? Okay. Uh-huh. This is 73 only? Okay. Okay. I just calculated a few of them. You can do the rest. Clear? Okay. So as you guys were mentioning the plaster, so now we are moving towards the topic which has the plaster, okay, and that all comes under internal finishes. Okay, so we have the substructural work, which includes the groundwork, topsoil, bulk excavation, filling, everything. Then we have, this is part of substructure. Then we have the substructure itself, the foundation, the column, and so on. And then we have the superstructure, okay, and then we have the walls. And now we are going to the finishing aspect. So in NRM, we have section 28 and 29. Finishing has a lot of things, okay, and we may not be able to, like, what we are covering may not be the only things. There could be many more things, because finishing is something which is related to aesthetic, okay. So this will look good, let me do this and do this, okay. You left all this, right, in architecture. Why? Okay, so so finishing, obviously once the surface is ready, then you do the finishing, right? Okay, so we have the finishes, and this is mainly done to the floors, to the walls and the ceiling, okay. So finishing is for the floor, for the walls and the ceiling. So you have to keep in mind for every room these three items: finishing to the floor and the wall and the ceiling, okay. Like it's a checklist, okay. What finishing I am doing at the floor, what finishing I am doing at for the wall, what finishing I am doing at the ceiling, okay. You have to check this in every room. And finishing can be made up of plastering. Obviously plastering is required for the wall, okay, and the ceiling, okay. The floor may or may not have. Then we have floor screeds, which are required mainly for the floors and what you were saying in your presentation at the roof, okay, the top slab. So there could be screeding on that one as well, okay. There are two main purposes of screeding, which is insulation, okay, and protection from moisture, extra protection from moisture, okay. So if you have rain or something, we don't want the water to seep into it, so screeding provides you an extra layer, okay. And screeding can be made up of different materials. Again, screeding is it can be made up of asphalt as well, okay. Screeding can be made up of asphalt, screeding can be of cement, okay, anything which you can stick on the ground, okay. Or there could be screeding layers, screeding membranes, okay, and these things as well, okay. But it is for the flooring, okay, or the top roof. And then we have the tiling, and the tiling can be for, you can see the tiles here at the bottom of the wall, okay. And if you go to kitchens and toilets and these things, then you will see the tiles are up to some height, okay. So tiling can be for the wall as well as for the floor, okay. And sometimes we have sheet finishing on the floor as well. So instead of putting different materials, you put a sheet and you stick and so on and so forth, okay. And this is mainly done you know, at if you have gone to gym, and you know, so they do the sheet finishing, okay, because they want the specific, like, they don't want you to get hurt when you fall and leave their gym and so on, okay. Then you can have, as I said, it can go up to your imagination, okay. These are usual items. You can think of any number of decorative items which you want in your room, in your shop or whatever, okay. So these are not limited. So for decoration we have NRM section 29, and for suspended ceilings we have 30. What is suspended ceiling? What is a suspended ceiling? Anyone? What is the suspended ceiling?
Maybe I think there's no columns in the middle.
Huh?
Maybe there are no columns in the middle of them.
No. They are suspended from the real ceiling. They are suspending from the top. And remember, we are not talking about structure. This is what? Which topic is this? Huh? Plaster? No. Plaster is a part of it. What's the topic? Finishes. Even if you say plaster, So it cannot be the real ceiling, right? It cannot be the structural element. Okay, it's something which you are doing extra for finishing, for decoration and so on. Okay, so now think about what is suspended ceiling. So there is already a ceiling, there is already a slab. This is something
It's not.
extra. It's not on the column. It doesn't have to, it has nothing to do with the column and the beam. It is suspended from the real slab. So there's a real slab of concrete or steel or whatever. And this is suspended from it. This is suspending from it. Okay? Can you see it? Can you see it? Everybody is looking at my face. Like you will see the ceiling here. No, ceiling is where? Up. So look up. Do you think this is the real concrete slab? No, right? So this is the suspended ceiling. Okay? I don't know what they call it here. Pakistan we call it false ceiling as well. False ceiling. Or fall ceiling. I don't know which one is true. False ceiling. So it's a extra, something extra. Okay? So if you remove this, you will still see the concrete slab. Okay? Somebody who is at the first floor, okay, and they have this ceiling for him. If they remove the ceiling for the guy at the first floor, I will not fall down. I'm not standing at the false ceiling. I'm not standing at suspended ceiling. I'm standing on the real slab. Okay, this is the real slab. Okay, so this is why it is part of finishing. Okay, you will see it in malls, in big halls here, mainly for the air conditioning. Okay, so they have the pipes running through it, and now we are using it for projection as well. Okay, and lights and so on. Okay, so for these type of items. Okay, so if we put it in the real slab, there will be too many holes there. You have seen the pipe for the AC, right? The AC ducts, they are big. If you try to pass through them from the pass them through the concrete slab, you need this much hole. Huh? You will have more holes than the slab itself, and you cannot put steel there. You have steel in the slab, right? Whatever slab you are using. So we cannot do this. And then you have this is hanging from somewhere and so on. Okay, so what we do, we put a false ceiling, and that false ceiling is basically, so all your accessories or amenities or your fixtures are now outside the slab. They are not inside your concrete slab. They are not passing through the concrete slab. You are getting my point? They are just passing through the wall and they go inside and you don't see them. Okay, you see a plain slab there. Okay, but this is not the real one. Got it? Okay, and it has nothing to do with the structural item. Okay, yeah. Before you go on and start calculating the quantities, we said we prepare a list, right? Before we start calculating the quantities, we prepare a list. What is that list called? Takeoff list, right? So finishing, because there are so many, and you have to count it for each floor and wall and ceiling, and for each room, and each room it can be different, right? Your living room is not the same as your bedroom. Your bedroom is not the same as your kitchen. Okay, so in each room it can be different, and each floor could be different. Okay, so that's why they advise that you prepare a complete detailed list for finishing separately. Okay, and this list should contain the room where you are doing it. Are you doing it in the ceiling or the floor or the wall, and what type of finishing you are doing, and the room and the floor. Okay, so all these things are mentioned. You can see the sample table over there. It's just a sample. Okay, so you can see the finishing for the ceiling and the floor. It's in different columns. You can see the room in the first column, and you can see the floor in this column. Okay, on this floor we are doing it. Okay, and this is just the key, the notations. Okay, so P1 means what? You come here and you see P1 means what. Okay, these are their own notations. You can change them, no problem. Okay, so this is done on project basis. There is no fixed template here. Okay. So it will obviously, whenever you make the list, it helps you check your calculations later on. It makes sure that if any information is missing, you can take it from the client at the start. Okay. So these are the main advantages, and yeah, this is normally provided by the architects. Okay, and obviously it's a completely architectural item. Okay, civil design has nothing to do with it, but obviously quantity estimation is important, right? Even if it's not your business, still you have to calculate the quantities. And by the way, you may still have to calculate the quantities for the other works as well, electrical and plumbing and so on. Okay, so in the field you may have to deal with them as well. Okay, but anyways, you have a limited course. So you can subdivide your items into these things: floor finishes and screeds, ceiling finishes, wall finishes, and then we have cornices and skirting. So you can see the skirting, I already mentioned it, okay, the bottom part of the wall. If you are doing any extra finishing at the bottom part of the wall, that is called skirting. If you are doing any extra finishing at the top part of the wall, that is called as a cornice. Okay, I cannot show it here in the room, but there are some other pictures in the other slides. And if somebody doing something like this in the middle of the wall, okay, some extra finishing in the middle of the wall, an extra layer or an extra item in the middle of the wall, they call it dado rail. Okay, so this is all part of these things. Okay, the extra finishing which you are doing for the walls. Okay, if the ceiling heights and the construction are varying across different floors, you should do every room and every floor differently. But if they are the same, then you can use the time sink method and you can multiply different rooms together and different floors together as well. Okay, there is no problem. For area of the floor and the ceiling, normally they are same. You are doing your own program here. What? The area of the floor and the ceiling will be equal, right? Okay, agreed. So you can take them together like we did for the girthing and everything. Okay, so the areas can be taken together, and yeah, in some cases in the floor you may have an opening for something. Okay, because floor may have opening for water, opening for if there is a staircase or something. Okay, so your floor may have an opening. You can do the deductions later on. Okay, but deductions are only done if the opening exceeds 1 square meters. Okay, if the opening does not exceed 1 square meter, then we just ignore it. Okay, just part of the wastage which you have to consider in your project. Okay, the floor finishes are measured till the base of the wall. Okay, all floor finishes are measured till the base of the wall. We do not deduct anything for the doors, because doors usually open till the wall, right? So anybody who enters the wall, he will step on the floor itself. Okay, so there is no deduction done for the area which is under the door. Okay, I'm not talking about the area of the door. I'm talking about the area which is under the door when you open it. Okay, so there is no deduction done for that, because the door usually opens completely till the wall. Okay, so that area is usable. You use it, right? You open your door and you have the whole area which can be used. Okay, screeds and floor finishes, they are normally have the same area. Then we have the ceiling finishes, which are again taken from wall to wall. Okay, from one wall to the other wall. Okay, and yeah, you can use as structural dimensions, and the beams are included usually in this. Okay, and you can make adjustments later on. So when you are calculating it for the first time, you can include the beams with it. Okay. If majority of the ceiling finishes are identical, then you can measure the ceiling over the internal walls and partitions as well. So I have, for example, this room, I have multiple classrooms here, right? Okay, but all of them have the same type of suspended ceiling. So I can take the total area. Total area will have the walls as well, right? So I can make the deductions for the walls later on. Okay, provided that they are same. Okay, so you will do one big calculation for the whole area, and then there will be small calculation for the deduction. It will be easier rather than doing 10 rooms one by one. Okay, and this is what they are saying about the finishing, but you can keep this rule in mind, that if I take the total area, I have to just make one deduction. This will be easier rather than taking one area for each room. It will have too many rows and too much calculation. Okay, so just keep this guideline in your mind. Okay. Okay, for the wall finishes, again you need the girth, right? You need the perimeter. So you take the perimeters and you can add the perimeters of the rooms which have the same height and the same finishing, like we did for the walls just now in the example. Okay, all internal walls were taken together, right? Okay, because they are made up of same material. So if you have the same finishes and the same height of the room, you can add all the parameters together. Okay, so I have 4 walls in this room, 4 walls in the other room, and 2 rooms on the next floor, but they are the same height and same finish. Okay, so I will add the girth of all of them together. Okay, so this can be done. As I mentioned before, for the measurement, we ignore the openings for this time, and later on, when the openings are actually calculated, we can subtract them. Then we have, so I was mentioning, cornices and coves which are at the top of the wall. Okay, so skirting is at the bottom and cornices are at the top. Okay, so it's usually around the entire room, and it does not require any deduction later on as well. Okay, cornices, they are around the entire room, and we do not need any deduction for even the walls and the doors later on as well. We keep them, the walls and doors and windows are usually under the cornices. Okay, we do not disturb them, so it's usually very straight. You take the entire length of the room, entire perimeter of the room, and you add them together, and paint work for the wall and paint work of the cornice is taken together. Okay, so the paint work of the wall already includes the cornice, because you take it till the top of the, or till the ceiling. Okay, we'll do the example next time. We didn't do the